Hello friends, welcome to Geometry on Nurse, which is a wonderful class where you learn a lot about shapes and proofs, and it's a nice little break from algebra. So let's start. Here's where section 1.1 starts in our book, what's called points, lines, and planes. So here we sort of start with the foundation of geometric shapes and what everything is made out of. In our suggested optional materials for our class, we said maybe get some flashcards because you're going to learn a lot of vocabulary and a lot of theorems and what are called postulates. So as you have them down here in your notes, feel free to use flashcards to also write them down to help you memorize them. All right, folks, let's start with the basics. What the heck is a point? Another word for a point is just a dot. There we go. That's a point. We're done. But notice we can label this point usually with a capital letter. This is point A. Over here I have point D. So points are just dots. They don't really have width or length or depth. There's a dot, but we use capital letters to label them. Now, if I string a whole bunch of points together, I can make what's called a line. And a line is made up of an infinite number of points. And it just goes on forever. But it's hard to draw forever, so we use the little arrowheads off to the side. Here's a line. Here's another line. But notice that it goes on forever on both sides. A couple ways that we can label this line. We can just use a small lowercase letter. This is line A. Over here, this is line M. Sometimes it's a little bit of a cursive lowercase letter. Or if by chance that line is going through 2 points like A and D, we can call this by the points that it passes through. This is line AD. And then to show that it's a line, look what we're going to do. We're going to put a little cute symbol on top that's like a mini version of a line. Hey, that's line AD. That's a line that goes through A and it goes through D and it goes on forever. Would it be legal, do you think, to write it like this? Is AD line and line DA the same? Yeah, they are. You bet. It's a line that goes through D and A and goes on forever. Absolutely. Okay. Well, that's 1 and 2 dimensions. Let's stretch it out even more. Not 3 dimensions yet, but if we stretch out a couple of lines, we can make what's called a plane. And you might have seen planes back in algebra that look like this, the coordinate plane. And yeah, that works really well. But the way that we generally visualize planes in geometry are something like this. That's a plane. It's like a flat piece of paper, but like a line, you have to imagine that these sides all go on forever. But that's hard to draw. So we just have to imagine that this plane on the screen is going to go forever to the left, forever to the right, forever to the top of the page, and forever to the bottom of the page. But we sort of visualize it using this sort of flat representation, almost like, if you know it, like a parallelogram, which we'll get to in later chapters. All right, well, what if we label this one? We can call this plane A, usually with some kind of letter inside. Or, just like we did with a line, if there are any dots or points inside the plane, say A, B, C, we can call this plane ABC. We don't have to put an additional symbol on that like we did with a line. It's just plane ABC. So that's a plane that goes through points A, B, and C. So do you think I could call that plane CBA? Would that be okay? Sure. Can you give me a couple other examples? We said plane A, plane ABC, CBA. What others can you think of? Ooh, how about BAC? Sure. And therefore CAB. What else? How about ACB? And therefore, how about BCA? So all these are legit ways of calling that plane. Notice that we use 3 letters. We have to use at least 3 letters for a plane because if I actually just call this plane AB, do you see that I would actually just be describing a line? So if we want to call it a plane, we do have to include 3 letters if you want to do this way, or a single letter if you see a single letter in one of the corners of the plane. But generally, this way over here is the way we call planes. So that's basically 2-dimension. Space, well, that gets to sort of all points in the air and around you. And that's kind of hard to draw too. And we won't really ever have to visualize or draw space, but think about maybe a sphere or a globe or a ball that just, again, goes on forever, like the universe. But in general, I'm going to put parentheses around it because we don't really talk much about space. We keep everything kind of flat in just 2 dimensions. Now, we can group points together in a certain way. If I have, say, point A, and how about point B? Let's include point C over here too. I got 3 points. Notice I could actually kind of draw a line through all 3 of those. There you go. Hey, sweet. So they're all on the same line. So since they're all on the same line, they are co-linear. So you can see line in there, and you can see co meaning together or with. So this is all on the same line. 3 or more points that are on the same line are called collinear. Well, then what do you think non-collinear is? Yeah, not all on the same line. Let's see, how can we draw this? Here's A, here's B. Could you draw a line through A and B? Yeah, so we got to draw C somewhere else where it won't be on the same line. How about over here? There's no way that I could legally draw a line that goes through A, B, and C unless I curved around, but we can't do that, right? They have to be straight lines. So these 3 points are non-collinear. They're not on the same line. Okay, well, we can also talk about, how about on a plane? Well, you know what collinear means. What do you think coplanar means? Did you say same plane? You got it right. So let's draw 3 points that are on the same plane. Well, that's not too hard, right? Let's just draw 1, 2, and 3. Those 3 points, A, B, and C, are all on this big plane here. Now, non-coplanar over here is kind of tricky, folks, especially because I'm doing it here on this sort of whiteboard screen for you. But can you imagine, I've got point A, I've got point B, and I'm going to lift my pen off the screen and sort of draw a point C above the screen. That might work, but I think I need to add another point. Let's try this. A, B, and C. Do you agree that those are coplanar? Yes. But now I'm going to draw a point D, and you have to imagine that point D is actually off of the screen here, above A, B, and C. Almost like you're going to make a big pyramid in a way. Now, because they're off the screen, they're not on the same plane. A, B, and C are on the same plane. They're on this plane. They're on the screen. That is on that plane. But D is not on the same plane as plane ABC. So those would be non-coplanar points. So notice that coplanar points can be 3 or more, but really non-coplanar really has to be 4 or more in order for that to happen. Good job. All right, now that we can talk about the basics, let's go even further. I'm going to take a line here. It's a line because you can see the arrowheads going off to the sides. But I only want to take a small portion of it. I'm going to stop at A, I'm going to stop at C, and I'm only going to talk about this part here in between, folks. We call that a segment. That is segment AC. And the segment has endpoints on both ends. So it stops at A, it stops at C, and it don't go no further. Can I call that CA? Is that okay? And yes, I can. But to make this look different than a line, remember how we put the line symbol above it before? Here, we're just going to put the segment symbol above it. So that's segment AC, and this is segment CA. Sounds good? Now what if we sort of mix it up? Can I do kind of a hybrid between line AC and segment AC? That's actually called a ray. Look what I'm going to do. I'm going to take my segment line up here. I'm going to maybe start at A. I'm going to go through C, but I'm going to keep going. So do you notice I've got an endpoint on the left and it's going on forever, arrowhead on the right? That's called a ray. A ray has one endpoint. Only one endpoint. On the other side, it goes on forever. I could have drawn it that way, or I could have drawn it that I start at C and I go through A, but I go on forever that way. So it only has one endpoint that goes on forever. So I'm going to call this ray AC, but now the notation on top is really important, folks. Check this out. This is ray AC on top. That means I start at A and I go through C forever. So I'm going to draw it like this. I'm going to draw a little mini ray, but I'm starting at A and I'm going through C. Up here, This is not the same thing as this. I can't draw this. Can you see how that's different? That would go from C and go towards A, and that's not what's above here in the picture. So generally we write it with the endpoint first, and then going towards the point that it goes through. So can you label this one up here on the top right? That would be ray C A, because it starts at C and it goes through and toward A. Could you write that as AC and do this? Yeah, that's actually legal, but we just don't like to write it right to left. We usually like to do left to right. So that's what a ray is. Now if I take two rays and I'm going to paste them together, back to back, I'll have what's called opposite rays. How about I have AC over here, and I'll put B over here. So let me draw ray AC, but then I'm going to go the other way and draw ray AB. Those are opposite rays that go in the opposite direction. And look what it makes. It actually makes an entire line. And there you go. All right, good job on that, friends. Now, let's keep going and talk about something really important that's going to lead into proofs and deductive reasoning later in chapter 2. But we get a little peek on it now. It's something that's called a postulate. A postulate, or some books call them axioms, but we don't use that word too much. It sounds cool, though. Postulates are just things, statements, sentences that are just accepted without proof. We don't have to prove it. Some things we will, and those are going to be usually theorems. But postulates, no, we just accept it. You don't have to prove it. What's 1 plus 1? It's 2. Do we have to prove that? No, it's just a postulate. It's just accepted as being true. We don't have to prove it. Those are great. So these are things that we're going to learn. We're going to realize, oh yeah, that makes a lot of sense. We don't have to prove that. And those are called postulates. It's great to have flashcards for these. Some of these have titles. Some of these just have long words. So you can write these out as postulates. So now, we would sometimes do these through our classes, and we would do these in groups. So if you see the word group questions or anything like that, this is mainly just for you. So a couple questions for you, friends. Ready? Here's a line here, right? You see the arrows going on forever on both sides. How many points do you have in a line? See, there's one. There's another one. Another one. Another one. I feel like I can keep going. If you remember in the beginning when we said what makes a line, it's basically an infinite number of points. How many points in a line? There's an infinite number. Or you can use the infinity symbol. It'd be really, really cool. Now, what's the smallest number of points that you really need to make a line? It's got to be a unique line. What that means is when you draw it, there's only one line that can go through it, not many, many. So for example, if I draw a dot over here or a point, I can draw a line through it. Sure. There you go. Oh, but wait, I can draw this line through it too. Oh, and this line too. So this is not a point that's going to give us a unique line. It's going to give us many, many lines. In fact, infinite lines. So I feel like 1 point's not enough. Let's try 2. Okay, 2 points. There's my line. Cool. Now, is there another line that I can draw through it that's not the same line? No, not really. You just get the same line back again. So what's the smallest number of points you need? You need 2. 2 points help you to determine a line. Let's go up a notch. How about a plane? How many points in a plane? And I can go on forever. So what's your guess, folks? Yeah, I would say infinite number. There's an infinite number of points in a plane. And again, remember, even though we draw it as that little small four-sided figure there, remember, these sides are supposed to go on forever. We just can't draw that. But that really means there's an infinite number of points. Same question would we have with the lines. How many points do we need to make a unique plane? If I draw point A, and over here point B, I can draw a plane that's pretty much right on our screen here. But then can you imagine an actual plane going through the screen from up on top? It's kind of hard to imagine, but imagine I'm above the screen and going down. There's another plane that would go through AB. So that's not unique. So I feel like I need to add another point. Point A, B, and C. That would be good, because I could draw this plane, as you see, would go through A, B, and C. Now, you might think, oh, well, I could draw a bigger plane like this, Mr. Brown, that goes through A, B, and C. But remember, planes go on forever. So do you see that the brown plane is actually the same thing as the green plane because they would both go on forever. So the green and the brown planes are both the same. So really, 3 points are enough to make a unique plane. Okay, so if it took 2 points to make a line, 3 points to make a plane, if we went up a dimension, what do you think about space? How many points? And it would be 4. And we don't have to show that. But let's put that all together in one big postulate. Again, if you have flashcards, these are great things to write down and help you memorize. Here's our first postulate. Some of these postulates have titles, some of them don't. Some books put numbers, like this is postulate 2.1, but we're never going to memorize the actual number of the postulate because some books have different numbers for others. Some books don't have numbers. So when you say 2.1, I don't really know what that means. So this is just a postulate. Here's what it says. A line contains at least 2 points. A plane contains at least 3 points, not all in the same line, not all collinear, because that would give you multiple planes. And space contains at least 4 points. So I'll give you a second to pause the video if you want to finish writing that down. Or if you printed out these notes, then you've already got this written down for you. All right. So here's 2 points, folks. Can you draw for me all the lines that are going to pass through both of those points? Okay, I'll draw one. There we go. Okay, I need to draw another line if I can. Aha! No, wait. Remember, we have to do straight lines. So that is not legal. So are there any more that I can draw? No, that's it. I can only draw one line. Hey, there's another postulate for you. That actually means something. Through any 2 points, folks, you can only draw one single line. Or like they say here, through any 2 points, there's exactly one line and no more. You can't draw any more. It doesn't matter where you put your 2 points. Here's a point, here's a point. I can only draw one line through those. And that's it. That's a pretty good postulate. All right, next part. Let's draw 3 planes that contain all 3 of these collinear points. All right, well, these are collinear, but they're 3 points, so maybe I can draw more than one. Here's one. Again, that's pretty much like my whole screen here. It goes on forever. Now, can you imagine coming up above on top of my screen and cutting through this is another plane. So it's actually starting above my screen and cutting down and going through my screen and going under. It's kind of hard to draw these. Sometimes it takes a little bit of practice using a little bit of creativity, like this. Dashed lines kind of help show where it cuts through. This is definitely not an important skill for geometry, but it definitely does help. So that's a line, a plane, sorry, that's cutting through another plane. There's sort of where they intersect together. And I could probably draw more. Maybe one that comes over sideways, kind of diagonal. Not just directly on top, but maybe like diagonal through this way. So it leads us back to this. Can more than one be drawn? How many? I could keep going. I could keep going, infinite number of planes. Why? Because they're collinear. But watch what happens down here. What if there were 3 non-collinear? Let's try to draw as many planes as you can. Ready? Okay, we'll draw the obvious one, the one that goes through my screen. Goes far left, far right, up and down. But now I can't draw one that comes up above at all. No, I really can't. I can maybe draw one that goes through like these 2 points and goes through the screen. But I can't draw one that goes through all of them. It have to be like a really thick plane. But planes don't have thickness. They have length and they have width, but there's no thickness to them. It's like a sheet of paper. So really, I can't draw this orange one here. That's not legal. So how many planes can I draw through 3 non-collinear? Only one. That's a really important postulate, guys. Here we go. Through any 3 points, there is at least one plane, maybe more. But if it's non-collinear, we can only draw exactly one plane. Exactly one plane. So pause the video for a second to write that down, or if you have these notes already printed out, you're good to go. Okay, like I said, that's a really good postulate, and this is really important for real life examples. For example, if I need 3 points that are non-collinear, they're definitely going to be in one plane. And here it's going to be on the screen here. Why is that important? Think about these things in this picture. Do you recognize what these are? Yeah, they're tripods. What tripods do is they help keep things steady, like cameras or video cameras. But why? Why do they keep it steady? Look what happens on the bottom. On the bottom of each leg here is a point, right? That's where it touches the ground. How many points? 3. So how many planes can those 3 points go through? Because they're non-collinear, it can only go through one plane. That's why it's so steady. If you take, for example, a desk and you're sitting on your chair in the classroom, sometimes you sit in a desk and it's kind of wobbly, right? Why is it wobbly? Because you have more than 3 non-collinear points. So maybe 3 of them are in one plane, but that last one is kind of in a separate plane, so it's kind of wobbly. The most stable thing has 3 non-collinear points. And so a tripod is probably one of the most stable things you can use. Pretty cool. All right, let's use our example here. So according to that postulate, how many lines contain points A and B? And we said any 2 points, there's exactly 1 line. And if this is plane P, and plane P goes on forever and ever, then I guess line AB also is going to go through forever and ever. Now, if A and B are in the plane, does line AB also have to be in the plane? Yes, absolutely. The plane goes on forever, the line goes on forever. Imagine this plane being a sheet of paper that goes on forever. Then when you draw this line, it's always going to be in the plane. Here's your postulate. If 2 points are in a plane, then that line that contains the points, the line that goes through those points, is also in that plane. Absolutely. How about 2 intersecting lines? Let's draw this line here. Let's draw another one that goes through it somewhere. I don't know, maybe like this. And they intersect, which means they cross, and they cross right here. Okay, well, what does that look like where they cross? What would you do with that? That looks like an X right there, but it also looks like they cross in this little dot right here. Oh, a dot. Oh, a point. Ah, so the intersection of 2 lines is always 1 point. Is it more than 1 point? No, because we can't draw a line that sort of goes around like this and hits it again and makes 2 points. That's not legal because, again, it's a curved line. So if we're using just 2 straight lines, they'll intersect in 1 point. Okay, that's cool. Now here's the hard part. How about planes? Can you intersect 2 planes? Do they have to intersect? I mean, I guess they don't have to. If you have 2 sheets of paper that are just sort of side by side, no, they don't have to. So for example, if I'm holding my screen here flat and I put a piece of paper on top of it that's not touching it, no, it will never touch my screen, so it doesn't have to intersect. We call those parallel. We'll talk about parallel lines later. So here's 2 planes that do not intersect. 2 planes that do intersect, that's hard. So I'm going to take you all the way here on the bottom, and I'm going to cheat a little bit and show you a picture, because that's hard. Look at this beautiful picture. These are 2 planes, plane P and plane Q, that are intersecting. Can you see that? So plane P is sort of the reddish type pink plane, and plane Q is sort of this flat blue one, and they intersect. Look at the dashed lines. The dashed lines help a lot to see the 3-dimensionalness. So the dashed lines show that the plane goes behind the other one. And look and see where they intersect. When you take 2 pieces of paper and you cross them together, look where they intersect right here. Not at a point, but at a whole bunch of points. And in fact, if it's a whole bunch of points, it is you guessed it, a line. And here it would be line M. So there you go. What is the intersection of 2 planes? It's going to be a line. Big postulate here too, friends. When 2 planes intersect, then their intersection is always a line. And there you go. Go ahead and try to draw that in your notes if you can. It's beautiful, but it's hard to do. Well, friends, there is the end of the first section of geometry. Hope you did well. Great job, and we'll see you next time.